Hello everyone, and welcome to the AI Research Roundup. I'm your host, Alex, and today is May 6th, 2025. We're looking at an ICLR conference paper, published about 3.5 months ago on January 22nd, called Mind Over Body, Adaptive Thinking Using Dynamic Computation. This paper tackles model inefficiency. It proposes MIND, that's model introspection for a dynamically adaptive model, to adjust computation based on input complexity, using fixed-point iteration or FPI for iterative refinement. Alright, so this figure on page 2 really lays out the MIND architecture. You can see how the introspection network that MLP block analyzes the input activations. Then, based on that analysis, it decides the computational path. Simpler inputs get a quick prediction, while more complex ones are routed through more fixed-point iteration loops, effectively using more computation. This is key to its adaptive nature. Building on how MIND works, this table on page 5 then details the MIND transformer settings. We see it has 6 layers, a model dimension of 512, and importantly, fixed-point iteration can be applied to 1 to 6 of these layers. This highlights how that dynamic adaptation we talked about is configured, allowing it to efficiently tackle language tasks with impressive results. Okay, so this next figure from page 6 really visualizes that dynamic adaptation in action, this time on a random dot movement task. You can see along the x-axis, as, quote, problem difficulty increases, the model generally uses a higher, quote, number of FPI layers. This clearly shows how harder problems are adaptively tackled with more computational effort, engaging more layers in the fixed-point iteration. And this figure from page 7 further illustrates that dynamic adaptation, this time on ImageNet. You can see for easy inputs, the model predominantly uses just one layer fixed-point iteration. But as complexity increases to hard, there's a clear shift with a much higher percentage of inputs engaging 3 FPI layers. This really demonstrates how it adaptively deepens computation for more challenging images. Okay, so this table on page 8 really drives home the efficiency point we've been discussing. On ImageNet, the MIND model achieves a remarkable 96.62% top 5 accuracy, with only 5.31 million parameters. This significantly outperforms both RESNET50 and EfficientNet B7, which use substantially more parameters, underscoring the power of its adaptive computation. It's a clear win for efficiency and performance. Alright, and this same table on page 8 also shows us how MIND performs on language tasks. For instance, the MIND transformer achieves an impressive 88.7% F1 score on Squad version 2.0 with 112 million parameters. This actually outperforms RobertoBase, which uses more parameters, again highlighting that great balance of performance and efficiency we've been seeing across different domains. It's really quite versatile. So, to wrap things up on this MIND architecture, it's clear that its ability to dynamically adapt computational effort based on input complexity is a real game changer. This leads to strong results with notably fewer parameters, as we've seen across different tasks. Well, that's all for today's AI Research Roundup. Thanks for joining me. I'm Alex, and I'll see you next time.